Hi to everybody. I was hoping that somebody will stay here for my presentation, and I'm very happy to see you all. I was running all this morning and I thought that I will never need another heating in my life, but let's hope that we will need some heating in future and that the climate will not change much, that we will still have a need for what I will present you now. I'm thanking very much to Sheila. Her presentation was an incredible introduction to what I will state today. So what we are speaking today is called Climate HVAC Solutions, focusing on heat pumps that we are manufacturing as our solution. Kotlarnica is our company. I will just briefly go through. We are focusing on industrial refrigeration, both ammonia and CO2 plants, commercial refrigeration, HVAC systems, and large-scale ammonia heat pumps design and manufacturing. The first purpose of this presentation is that I would like to describe you engineering and R&D aim to optimize utilization of air source heat pumps in cold winter climates. The steps that we will see is defining cold climate regions in Europe and globally, to define the energy and HVAC solution trends by 2060, and to speak about optimizing HVAC system solutions in line with ASHRAE and RIVA and local, of course, design criteria here in Serbia. Unique Kotlarnica solution at European market is Kraftwerk EVI optimized air source heat pump solution. This is enhanced vapor injection system that we are applying in our heat pumps, which I will describe further in the presentation. So, believe it or not, 20% of the world is in polar zones. This was the first step that we thought of to think about what is our market and where we would like to see ourselves. If you see the map which is sourced by European Commission, you will see that the big part of Serbia and former Yugoslavia is coming to the very cold area, and that is again a part that we see as a good potential for the systems and solutions that we will discuss. I also took some other parts of the world. I will not go in details with these parts, but I will stick to Serbia, where we can clearly see that in 2016-17 winter time we had 65 to 81 days in central Serbia below zero, and 7 to 22 days in cities below -10. That is official data coming from Serbian Hydrometeorological Society, and from that perspective, again, we are very happy to see that potential for our product is also existing in Serbia. Energy and utilities grow global trends. You for sure know, and that was obviously an important part of ASHRAE, the presentation that I was following, presented by Sheila. We have also idea to participate in this fight against energy sources which are not green enough to be something that we would like to aim for future. So fossil fuels are something that we would like to see very much out of from the solutions that we have in our portfolio. If you see the RTC reference technology scenario is to remain at the zero level by 2050, then we speak about 2DS, which is 2 degrees difference, 50% of limiting global warming by 2100 with only 2 degrees global warming, and even more strict the scenario is to limit to 1.75 the global warming by 2100. This is clear definition of what we would like to achieve with focusing to the product range that we have in our portfolio. And somehow the computer will not change slide now. I will try to, here, we are there. We also focused on some pricing of levelized cost of electricity in certain parts of the world. Here we have some example from US national leverage. Then we discussed what are the important facts and what are the energy demand of the buildings that we have in the different areas of the world. And of course, altogether we touch the base with leveled cost of heat, which is very important driver for us to see where do we stand with applying heat pump solution in for example, this part of the world. For that, I will use the analysis that was made by the World Bank in Serbia, and if you see that for new individual heating systems, heat pumps have really the lowest leveled cost of heat of any other source, including biomass. In Serbia, we have 36 euro per megawatt hour cost of heat pump energy, with comparison to biomass using wood pellets in stoves or traditional stoves. We come with a really very effective and very competitive solution. So this driver is again promoting solution with heat pumps, which we are discussing in the moment. Heat pumps as key market findings, of course, you know much about that, but I will just refer to some most important findings that we've found. Of course, the best possible solution is water source heat pump, but due to all these the administrational things all over Europe and the possibility really to track the water as geothermal source, we have found that air source heat pumps and geothermal heat pumps are also something to be considered in high scale. So what we are focusing with our solutions is air source heat pumps, which are of course designed in our case to support all these needs in the markets which have this cold climate, as I just explained in the beginning. The targets, the trends in global markets are stating, of course, by research done by OECD, that by the year 2060, heat pumps will take more than, or at least around 50% of all heating market globally, and therefore, again, we have clear idea to continue this development that I'm just presenting to you. So coming further to design fundamentals which are present in Serbia, we stick to the design temperature which is present in Serbia, which is -12.1, and for this design temperature we designed the heat pumps in the way that they are optimized for this utilization. The main ideas is implementing systematic optimization techniques, which is based on cold climate needs that I explained before. Heat pump design was optimized in our case using a validated component based on the economized vapor injection EVI model, and this is something that we wanted to extend our air source heat pump envelope, maintaining high level of COP. Meaning the product cost on the acceptable level, we achieved using our partners in China, where we actually manufacture our heat pump. And the target is, of course, to have developed a stable system efficiently working in cold climate conditions, eliminating backup system needs. This is very important for us because we would like to have as much as possible of heat need made by using only heat pump without any backup, which would increase the utilization of the fossil fuels sources, which we would like to avoid. The standard air source heat pump is described here. You see that the standard solution is, of course, using the source of air, soil or water through the evaporator, evaporating the heat and using that heat further in the process. Our idea is, of course, to add vapor injection. We are doing that exactly in the way which is presented in the slide. We were considering two possibilities: to add liquid refrigeration injection, inject a liquid state refrigerant into the compressor. This allowed us to have economizer cycle to improve the cooling and heating capacity at the same stroke of volume of the compressor vapor refrigerant injection. And from the other side, vapor refrigerant injection was considered to have decreased the extremely high discharge or temperature of the compressor, ensuring the reliable system of operation. We chose to go the way with adding liquid refrigerant injection, and of course I am showing now to you the system that we are using. We are using Copeland EVI compressor for our heat pumps, which is allowing us to get to the extended envelope, which I will just present to you. We achieved that our heat pumps, air source heat pumps, like no other heat pump in the market, are working down to minus 30 degrees. Kraftwerk model, which we are discussing today, is producing hot water 55 to 60 degrees, even at minus 20 degrees. And our COP remains higher than 2, even with the temperature higher than minus 20 degrees. So this is something which is very competitive at the market, and for this we are very proud. I'm showing to you the table which is coming out from our design stage and laboratory tests. We of course have the tests done in Serbia during last winter, which was very cold, as you saw it already. So we also implement this solution with some other systems that we are using in our portfolio for different kind of plants, industrial projects and commercial projects. And I will just shortly give you the conclusions. Kraftwerk K model is designed in the way achieving all preset targets. Methods for increasing the performance of air source heat pump proven as proper and reliable. We have it proven commercially, and we have it proven in laboratory tests. Economized vapor injection compressor utilized in a Kraftwerk air source heat pump efficiently runs in cold climate. Advantages of using system heat pump pulsar diffusion system in HVAC solutions that we already made, for example, in IKEA project in Belgrade, proved to be very efficient and very reliable for commercial demands. As a result, we have reduction of installed electric power capacity, developed EVI, air source heat pump stable, working efficiently in cold climates down to minus 30 degrees, keeping higher efficiency, as I said. And of course, we have very high cost optimization on both sides, the investment cost and running cost, because our heat pump doesn't demand any backup system. It works 99.9% of time without any backup system, and therefore we keep very high energy efficiency during all the winter time. And from that perspective, our solution is very much satisfying all the needs that I described before. In our development plans, we have two-stage flash separation cycle diagram, which is going to bring us to the minus 40 degree. We will have low pressure and high pressure compressor. We will make 2 stages compression. Of course, we plan to add another expansion valve to have a high level of COP at 1.5, even at the temperatures of minus 40 degrees. This was very fast presentation because I got some instructions to speed it up. If you have any question, please feel free to ask. I will be very happy to answer to you.
Okay, thank you.
Ja bih prvo pitao, mislim ovdje, da sam ja previdio i nisam video da COP nismo vidjeli koliki je.
Evo sad ću da vam pokažem tablicu, ako budem uspeo da pokrenem.
Pitanje glasi, COP za ove uređaje bi volio da vidim.
Ako, ne znam koliko se vidi ova posljednja tablica dole.
Slabo se vidi.
Recite mi neki primjer temperature koja vas zanima.
Za naše temperature, da kažemo minus 20.
Na minus 20.
12 nek bude, ajde, za projektne naše temperature.
Za minus 20 ću vam prvo reći, za minus 20 COP je oko 2, u zavisnosti koju temperaturu vode proizvodimo. A u temperaturama minus 12 imamo COP koji je oko 2,7.
Sa temperaturom kondenzacije koja bi bila?
Ovako, imamo temperaturu, ako hoćete da pričamo o temperaturi koja je 35 stepeni recimo za podno grejanje, mi razgovaramo o 2,7. Ako idemo na fan coil sistem, na minus 12 ćemo biti oko 2,30, 2,40.
Vi ste rekli da može da ide do 65 stepeni. Pri kojim uslovima može da je voda do 65 stepeni?
Na minus 20 proizvodimo 55 stepeni, sad ću vam ponovo pokazati envelope. Na minus 20, ako vidite ovdje, smo na 55 stepeni, 60 stepeni smo sve do minus 15, a sve do nule, to jest i na minus 2, negde proizvodimo vodu na 65 stepeni Celzijusa.
To bi značilo da je pritisak kondenzacije negde preko 40 bara, ako je ovo 410 ako sam vidio 410 tako.
Ja ne znam na pamet koji bi pritisak bio, ali ovo su temperature koje postižemo sa našom toplotnom pumpom, ja mogu da vam te podatke dodatno dostavim ako...
Da li je 410A?
410A je freon, jeste.
Mislim, ja sam sad imao problem da nađem razmenjivač toplote koji može da radi na tim pritiscima, koji je nominalno 45 bara da bi praktično radio na 40.
Patentiran je izmenjivač toplote baš iz tog razloga da možemo da postignemo ovo što imamo ovde.
A dobro, još jedno pitanje koje ću završiti. Kod otapanja, problem je uvek otapanje.
Dobro.
Kako je rešeno otapanje i da li ima neki poseban sistem za otapanje ili klasično otapanje?
Na različitim pumpama u zavisnosti od projekata koje radimo možemo da imamo više pristupa. Najefikasniji pristup koji nam se pokazao je da u multiscroll rešenjima imamo otapanje tako što otapamo uvek po jedan kompresor, a ostali rade. Tako da što duže vreme držimo pumpu u radu da bi mogla da postigne što bolji COP i što bolji efekat. U slučaju pojedinačnih scroll kompresora onda idemo sa nekom logikom koju kompjuterski vodimo, a sistem je standardni reverzibilni u kom to radi.
Multiscroll bi značilo da ima više rasanih krugova, ne više kompresora, nego više rasanih krugova.
Jeste.
Čiji se otapa.
Jeste.
Hvala vam.
Nema na čemu.
Možete da nastavite, you can continue. Hvala mnogo, thank you once again.